Hello everyone. Today we are going to start with the concept of angular projectile motion. As we know that projectile motion is the trajectory of an object when it falls under the effect of gravity. So if you project your object in a horizontal direction, it will fall in a parabolic path, and that is a horizontal projectile motion. But in angular projectile motion, you're going to project an object at some angle from the ground or from some height, and it will follow a parabolic path. But the difference between the horizontal projectile motion and angular projectile motion is that in horizontal projectile motion, the velocity is in the horizontal direction, the initial velocity. But in angular projectile motion, the initial velocity is at some angle from the ground, right? So today I'm going to show you how we analyze this angular projectile motion and what are the different quantities related to angular projectile motion. So let me give you an example first of all, like what is angular projectile motion and how does it look. So let's say this is a cliff on a ground, right? Let's say this is me, Anureet, standing on the top of the cliff. Just kidding. And I'm going to throw a ball at some angle from the horizontal, right? So let's say I'm going to throw it at some angle like this. So this is the path followed by the projectile motion, or you can say the path followed by the ball which is being thrown by me, right? Now, this angle with the horizontal is the launch angle, right? Now, I am already at some height h, or you can say, let's say y naught, initial height. This is known as the launch height. Now, the distance from the cliff and the point where the ball is going to fall is known as horizontal range. Now, the maximum height achieved by the ball in the air is known as h, the maximum height, right? Now, the important thing about this type of motion is that you are going to throw the object in the upward direction, right? But you know that the acceleration due to gravity is always towards the downward direction. So that means the force is in the downward direction, force due to gravity, but you are going against the force of gravity. So when you try to go against the force, your speed will decrease. So that means the speed decreases initially, and when it falls back towards the earth, that means again the object is towards the earth. That means its speed is going to increase. So that means at this point, at the top of the point, at the top where it reaches the maximum height, my velocity is going to be 0. But which component of velocity will become 0? Is it horizontal or the vertical component of velocity? Now, because we are dealing with the vertical component of acceleration, that means this is the vertical component of velocity that becomes 0 at this point, right? Now, let's say my initial velocity is u at some angle theta, right? Now, just give me a second. Yeah. Now, this is the horizontal component ux, and the vertical component is uy. I hope you understood the different variables associated with this angular projectile motion, right? So now let's move to the next part. Now, as I said that velocity is at some angle from the horizontal. So this is my horizontal component, this is my vertical component. Let's analyze the velocities or the vertical and horizontal components. Now, the horizontal component of the vector quantity initial velocity is u cos theta. The vertical component is given by u sine theta, right? Now, my next thing is like, how can I determine the maximum height achieved by the object in this horizontal projectile motion, right? Now, as I have already told you, for example, let's say my angular projectile motion is this, right? So at an angle theta, right? Now, at this point, my vertical component of velocity is 0, and my acceleration is, let's consider just the motion from point A to point B. That means the acceleration due to gravity while going from point A to B is in the downward direction. You are going up, acceleration is downward. So two opposite things in physics are represented by a negative sign. So my acceleration due to gravity would be negative g. Now, how can I find this maximum height h from the ground, right? Now, we know that we have equation of motion v square minus u square equals to 2as. Now, because we are considering the vertical height, I'm going to consider only the vertical components of displacement, velocity, and acceleration, right? Now, my vertical component of velocity at the highest point, final component is 0, minus uy. What was my uy? Isn't it u sine theta? Now, equals to 2 times acceleration is negative g, and this vertical component of displacement is my maximum height. Now, when I solve this, I'll get my maximum height as u square sine square theta upon 2g. So that's my formula for maximum height, right? Now, let's say the object was initially at some height y0, and you are going to throw the object from this height and it follows this parabolic path. Now, this formula is for this height, like this thing. Now, how can you find this total height? Now, you will say that the maximum height is y plus h naught. So you will just add y naught to this quantity, which is u square sine square theta by 2g. Now, next thing is, how can you find the time of flight, right? So now, how to find the time of flight? Now, as I said that the object is going like this, right? Now, in going from point A to B, initially my vertical component of velocity is uy, then it is vy, which is 0. Now, again, I have first equation of motion, which is v equals to u plus ad, right? Now, vy equals to uy, ay, and there is no horizontal and vertical component for time. Reason being, time is a scalar quantity. So now vy is 0, uy is u sine theta. Again, I'm considering motion in going from point A to B. So that means my acceleration is negative g, and this is t. So from here, my time in going from A to B, which is also known as time of ascent of the object, is equals to u sine theta by g, right? Now, that means this is my time of ascent. Now, time of ascent will be equals to time of descent, right? So this is equals to u sine theta over g. And if I talk about total time of flight, that would be time of ascent plus time of descent. Both of them are same, so answer would be 2u sine theta by g. Okay, now the last part of angular projectile motion is how to find the horizontal range. Now, horizontal range is nothing but my horizontal component of displacement, and this is equals to uxt plus half axt squared. So that means range equals to, what was my ux? Isn't it u cos theta times time of flight? So this t is time of flight, time it takes to start from the initial point till final point. So how much is the time elapsed between these 2 points is time of flight, right? So that is 2u sine theta by g, which we have just derived. Now, so from here, it comes out to be 2u square sine theta cos theta over g, right? Now, we can, what we can do is, now we have just derived, now look here, yeah. So now, this is u squared sine theta cos theta by g. So u squared by g, and can I write this as 2 sine theta times cos theta, right? Now, according to trigonometric identities, 2 sine theta cos theta is nothing but sine 2 theta. So this is my formula for horizontal range in angular projectile motion. So I hope you guys understood what is the time of flight, horizontal range, and vertical height achieved in an angular projectile motion, right? Now, okay, so Give me a second. Okay, so now, guys, in my upcoming video, I'm going to do some of the questions related to angular projectile motion and how to identify different physical quantities. And in the next video, we will also be doing various graphs which will relate different physical quantities in the angular projectile motion. If you guys understood the concept of angular projectile motion, press the bell icon and subscribe my channel for more upcoming videos. Thank you guys and stay safe and stay home. Thank you.